So in this experiment, experiment 4, we'll be demonstrating the double displacement reaction between sodium hydroxide and nickel chloride. A double displacement reaction occurs when two chemical compounds are combined and two compounds result in the product. So in a double displacement reaction, we'll have compound AB and compound CD, each with a positively charged element and a negatively charged element. This is the reactant side. When the chemicals are combined, two new compounds are formed, compound AD and compound CB. As you can see, the element A combined with element D because of their opposite charges, and the same for C with B. So, in this experiment, we'll combine sodium hydroxide and nickel chloride. We'll start by taking two 50 milliliter beakers and placing them on the lab table. And we're going to put 15 milliliters of sodium hydroxide in the first beaker. And we can label this beaker by double-clicking it. And now we're going to put 6 milliliters of nickel chloride in beaker number 2. And we'll label this one as well. I'm going to zoom in so we can see the reaction take place. Now we'll pour all the contents of one beaker into the other. We can observe the result of the compounds mixing. There we go. Okay, we can observe the result of the compounds mixing. They result in a clear aqueous solution, the sodium chloride, and a small green precipitate, the nickel hydroxide. So, let's see how this correlates to a balanced equation.
Alright, so in the balanced equation we have 2 moles of aqueous sodium hydroxide and 1 mole of aqueous nickel chloride. When we combine these, as in the virtual lab, it results in the products. A precipitate forms, the little green ball at the bottom of the beaker. That's 1 mole of nickel hydroxide here, and 2 moles of aqueous sodium chloride, the clear liquid in the virtual lab. If we look at the total and net ionic equations, we can better see how the reaction takes place. The total ionic equation shows the individual ions alone, which allows us to see the charges and which of these are spectator ions in the reaction. So, we can see that the nickel ion and the hydroxide ions in the reaction, which are right here, combine to form a non-soluble compound, which we figure out using our solubility rules, which is nickel hydroxide. Meanwhile, the spectator ions, sodium and chlorine, here, do not undergo a phase change. They remain aqueous.